Hello everyone, I am Ali Tariq from 10x Engineers. In the previous video regarding llama.cpp, I ran llama.cpp on QEMU and I showed you the performance of llama.cpp on RISC-V emulated instance. In this video I have here Banana Pi F3 which has 4 GB of memory and it has 8 RISC-V cores with the RISC-V Vector extension, RISC-V Vector extension version 1.0 to be specific, and it is running Piambu over here. You can see that the operating system name is Piambu 1.0.9 and it is a Debian based distro, and also you can see that it has 8 cores and it is a space MIT SoC. So here I am using Tmux session and I am not screen recording on the Banana Pi F3 itself. I have my personal machine which is running Linux, and I'm using SSH to connect with Banana Pi F3. Here I have Tmux window 1, so I'm going to switch to Tmux window 2. So here you can see that I have already compiled llama.cpp for vector extension as well as for scalar extension. It takes about 1 minute and 22 seconds and 1 minute and 24 seconds on the vector extension. On the left side you can see that I am using RISC-V Scalar extension which can be denoted by RV64GC, and on the right side you can see that I am using RISC-V Vector extension to compile, which is RISC-V64GCV. And on the bottom you can see there is an htop window running, and it shows the usage of cores and the workload on the CPU. It has 4 GB of memory. You can see that in the htop window too, and I am using 4 GB of swap here. So I am going to paste here the command which is used for compiling. Okay, so I have already pasted the command in the RISC-V 64 GCV window as well as RISC-V 64 GC, which is the scalar version, and I will be first running on the RISC-V scalar and then on RISC-V vector extension. So the scalar version will be on the left side, and you will be able to see the workload and the performance later on. So you've seen the performance on the RISC-V Scalar extension. It takes total time of almost 142 seconds and 51 tokens. So now I'm going to run it on RISC-V Vector extension. So you can see that there is a lot of difference in the performance when I run it with RISC-V Scalar versus RISC-V Vector extension. It is a lot faster in Vector extension. So there it is. It has taken about 23 seconds and 51 tokens. Okay, so there is one thing which I would like to show you, that is how you can change the and how you can mention how to compile llama.cpp for vector or scalar. For that you will have to edit the make file, and here you will have to search mark. And here you can see that there is a RISC-V RV64 GCV. This will be by default in the repository files, and if you want to compile it for RISC-V scalar extension, you will have to remove this V over here to like this and like this over here. So after this you will be able to compile it for RISC-V scalar extension, and you will be able to run it. And regarding the compile command, so I am using this command over here. The time command is just to see the total time the command takes to run. The main command over here is the make llama -cli RISC-V is equal to 1, and you can also skip this J flag, because it is just mentioning the number of jobs to run in parallel. For me it takes 13 minutes if the compile process is not cached, and it takes 13 minutes on both of the vector as well as scalar, because it doesn't matter if you're running on vector or scalar during the compile phase. This was all about the llama.cpp. If you have any questions, you can leave them in the comments. I will also post the model link as well as the repository link which I have compiled, but the model link can change as it has changed in the past too. You can also search on the internet for latest models. If you have any question, you can post in the comment. So that was all. See you in the next video.